In this video, I will be explaining you about the equation of motion of compound pendulum. Okay, so this is the question: derive the equation of motion of compound pendulum. So to write this derivation, you have to draw this diagram first. Okay, here is the x-axis and this is y-axis, and from this origin you are drawing a line like this. That is, this is a string, okay, of length L1. Okay, at the end of the string there is a mass, that is m1. Okay, m1. The coordinates of mass is x1 comma y1. Okay, you have to mark like that. At the point at this point you have to mark C also. Okay, because in our derivation you will use this C. Not, you don't write m1 or something like that, you will write C. Okay, so that is why. So here this mass point is denoted as C, and this string is extending like this of length L2, and here is another mass, and that is m2 of coordinate is x2 comma y2. Here at this point you are mark it as F. Okay, and now here you are writing drawing dotted lines like that, and here F an angle theta 1 formed, and here theta 2 formed. Okay, mark this as E, D, B. Okay, okay, is that okay? Okay, and the length from A to B is y1. Okay, and the length from B to D is y2. Clear? And D to F is x2, B to C is x1. Okay, these are the things that you have to mark in the diagram. And let's pass on to the beginning of the derivation. Consider a pendulum. Here this is a pendulum. Okay, consisting of 2 point masses. In this pendulum there are two masses, m1 and m2, suspended by an inextensible string of length L1 and L2. These two masses are at the end of the strings L1 of length L1 and length L2 respectively. The position of the masses is completely determined by the angle theta 1 and theta 2 between the deflected and equilibrium position of the string respectively. So here the position of the mass is completely determined by theta 1 and theta 2. Okay, based on theta 2 and theta 1, it varies. The position of the masses will vary. Okay, that is why they are saying it depends on. What depends on? Sorry, here is nothing like that, depends on. Okay, the masses, the position of the masses m1 and m2 are determined by this theta 1 and theta 2. Now if the rectangular coordinates of m1 and m2 are taken as, so here for m1 this is the coordinate, and for m2 this is the coordinate. It forms a rectangle, right? So that is what they are saying in the sentence. If the rectangular coordinates of m1 and m2 are taken as this and this respectively, now let's start to write the derivation. Okay, from this it started, but anyways this will proceed like a problem. Okay, consider a triangle. So here from the figure you are first considering this triangle. Okay, ABC. So consider a triangle ABC. So from the triangle you are finding sin theta 1 and cos theta 1. Okay, so sin theta 1 is equal to, we all know the formula. What is that? Opposite side by hypotenuse, right? So using that formula you will get this, and from this you can write this. And also you are finding cos theta 1. Cos theta 1 is what? Adjacent side by hypotenuse. Am I right? So from this you will get this, and from this you will get this. So you finished finding x1 and y1. Our intention is to find, our first intention in this derivation is to find x1, y1, x2, y2 values. Okay, so that process is going on now. So x1, y1 are finished. Now consider the another triangle CEF. So CEF means what? CEF. Now you are considering this triangle. Using this triangle you are going to find x2 and y2 values. Okay, so let's see how. So here sin theta 2 is equal to EF by L2. You will get this. Compare it with the figure, okay, so that you will understand. Now from this you are finding EF value. Okay, and similarly finding cos theta 2. From this you are finding CE value. Now you will find x2 and y2 value. That is x2 is equal to DE plus EF. X2 is equal to DE plus EF. It's very easy, okay? Just compare. This diagram plays a key role in this derivation. Okay, that's it. Compare it with the figure. X2 is equal to DE plus EF. So we have the value of DE here. What is DE? DE is what? X1. Why? This DE and BC are of same distance, or in the same distance, of same length. Okay, so that is why in the place of DE you are putting X1 here. Is that clear? X1 plus what is EF? EF is already, you have found that, so just substitute it, and here substitute X1 value, we already have that, plus and this value. So from this you are getting X2 value. Similarly you find the Y2 value. So here you can find the Y2 value. Okay, don't confuse with the signs. Okay, that is very important. Okay, is that clear? Okay, we finished finding x1, y1, x2 and y2 values. Now you are using that, you are going to find x1 dot, y1 dot, x2 dot, y2 dot. What is mean by x1 dot? You are differentiating x1. Okay, so that is why it is denoted by x1 dot. Okay, you are differentiating this x1. Okay, so that is why you are putting x1 dot. You are differentiating this with respect to theta. Okay, with respect to theta. So here have a look at this. You will get these values. When you differentiate x1 with respect to theta, you will get this L1 cos theta 1. That is sin theta 1. When you differentiate this, you will get cos theta 1, and then again you are differentiating this theta also, so you will get theta 1 dot. Similarly you do for y1, x2, y2, you will get this. Okay, have a look at this, you will easily understand. Now after finding all these, this is the second step of the derivation. Okay, what is the first step? You are finding x1, y1, x2, y2, and in the second step you are finding x1 dot, y1 dot, x2 dot and y2 dot. Is that clear? Now you are finding the total kinetic energy T. Total kinetic energy you are finding, and this is the formula to find the total kinetic energy. Is that clear? Now we have all the values. We don't have m1, so write m1 as it is. In the place of x1 dot square, y1 dot square, x2 dot square, y2 dot square, substitute the values. Okay, substitute the values, and here what you are doing is from you are taking from this, I think, right? Yeah, from this you are taking cos square theta 1 by 2 m1 L1 square theta 1 square. From this you are taking common, and so that you get cos square theta 1 plus sin square theta 1. We know that the value of cos square theta 1 plus sin square theta 1 is equal to 1, right? And this is the next term, 1 by 2 m1. So look at this. Okay, you are writing it. Wait a minute. Yeah, L1 square cos square theta 1 dot. Yeah. Sorry. Have a look at this. This is from this you are taking, from this you are getting this step. Okay, and from this you are getting this. That is, you are expanding this in a plus b the whole square format, and this is you are expanding this with a plus b the whole square format, so that you will get this. Okay, don't confuse with any signs or anything like that. Okay, have a deep look. Oh my